Welcome, everyone, to TechDaily.ai. We're about to embark on a truly fascinating deep dive today. We're talking about cloud seeding. Now, this is a specific type of weather modification, and it aims to do things like change precipitation, mitigate hail, even disperse fog, basically making it rain or snow when you want it, or maybe stopping it later. It sounds like science fiction, doesn't it? The whole idea of, making it rain or stopping it like something out of a futuristic novel. But it's actually very real. It's happening right now all over the world, adapting to modern challenges. Before we really plunge into the clouds, though, I want to give a huge shout out to our sponsor. This deep dive is sponsored by Stonefly. They're your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyperconverged VMware, Hyper-V Proximox cluster, AI servers, SA365, a turnkey security appliance, public and private cloud. You should definitely check out stonefly.com for more info. Okay, so let's get into those clouds.
It's a great topic because, yeah, what's truly fascinating here is the sheer amount of curiosity and, honestly, a fair bit of skepticism that still surrounds weather modification, especially with all the weird weather events globally we've been seeing lately, right?
Absolutely.
So our mission today is really to cut through that noise, try and give you a clear picture. We'll explore the actual science behind cloud seeding, look into its pretty rich history and surprisingly diverse uses. We'll talk honestly about its effectiveness or, the big debate around that, and cover the crucial environmental side, the legal stuff, even some of those wilder conspiracy theories that pop up.
Yeah.
And ultimately, yeah, connect it all back to the bigger issues like water scarcity and the tech solutions people are chasing.
Okay. Sounds like a plan. So, starting with the basics, how on earth do you even start to make it rain? What's the actual process?
Right, the core method, it involves dispersing specific substances up into the atmosphere. Think of them like tiny little magnets, but for water droplets or ice crystals. They act as what scientists call cloud condensation nuclei, attracting water vapor to form liquid droplets, or as ice nuclei, which encourage ice to form.
So, what kind of substances are we talking about?
Historically, the most common ones you hear about are silver iodide, potassium iodide, and even dry ice, solid carbon dioxide.
Right. I've heard of silver iodide.
Yeah, it's sort of the classic seeding agent.
Mm-hmm.
But the field is always evolving. Lately, there's been this growing interest in hygroscopic materials.
Hygroscopic. What's that mean?
It just means materials that are exceptionally good at attracting and absorbing moisture from the air.
Oh.
And a prime example, believe it or not, is just ordinary table salt.
Really? Just salt?
Yep, because it's so effective at grabbing water molecules. And another one that's emerged is liquid propane. It has this unique ability to produce ice crystals at slightly higher temperatures than silver iodide can.
Huh. So that expands the possibilities, the conditions where you could try it.
Exactly. It gives you a wider window.
So you've got these substances. How do they actually trigger the rain or snow? What are the mechanisms?
Good question. The science tries to basically mimic and speed up natural precipitation processes. We usually talk about two main techniques. First, there's static seeding.
Static seeding. Okay.
Its main goal is to encourage ice particles to form inside supercooled clouds. These are clouds where the water droplets are still liquid even though the temperature is below freezing.
Right, below 0 Celsius, but not frozen yet.
Precisely.
Yep.
And silver iodide is really effective here because its crystal structure looks a lot like ice. So when you introduce it into a cloud that's, say, between -20 and -7 degrees Celsius, it kind of tricks those supercooled droplets into freezing onto the silver iodide particles.
Ah, it gives them something to freeze onto.
Exactly. It acts as a nucleus. And that kickstarts the process that eventually leads to snow or rain falling out.
Okay, that's static seeding. What's the other one?
The other main type is called dynamic seeding. This one's a bit more ambitious. It aims to boost the overall development and growth of convective clouds.
Like those big towering thunderclouds.
Yeah, exactly. Cumulus or cumulonimbus clouds. Dynamic seeding works by releasing latent heat.
Latent heat.
It's the heat released when water changes state, like from vapor to liquid or liquid to ice. Seeding encourages more freezing, which releases this heat. That heat basically gives the cloud an energy boost, makes it grow bigger, rise higher, process more moisture, potentially leading to more significant rainfall.
So it's like you're feeding the cloud energy.
In a way, yes. Stimulating more vigorous updrafts and internal processes.
Okay, interesting. So how do they get these materials, the silver iodide or salt or whatever, up into the clouds?
Well, the methods for dispersing them have also evolved quite a bit. Traditionally, you'd had specialized aircraft, things like the Beech 18, Lockheed 18, maybe a Cessna 340. They'd fly right through the target clouds, releasing the seeding agents.
Flying directly into the storm, essentially.
Pretty much. Or another common method uses ground-based generators. You see these a lot in places like Colorado in the U.S. They release silver iodide, for example, from the ground.
And just hope it drifts up into the clouds.
They rely on natural atmospheric updrafts
Yeah.
to carry the particles up to where they need to be.
Seems a bit less precise, maybe.
It can be, depends heavily on the conditions. But now we're seeing newer approaches too.
Oh, yeah. Like what?
Well, the United Arab Emirates, for example, they've been doing some really interesting work since 2021 using advanced drones.
Drones for cloud seeding.
Yeah, but not just any drones. These are equipped with special instruments that emit an electric charge.
An electric charge? How does that work?
They fly at low altitudes and zap air molecules, basically.
Hmm.
The idea is that charging the particles helps them clump together more easily, encouraging droplet formation.
Huh. And does it work?
Well, they reported it contributing to a pretty significant rainstorm back in July 2021.
Yeah.
Al Ain got nearly 7 millimeters of rain over 2 days, which is quite a bit for that very arid region.
Wow, okay. Drones with lasers next.
Not quite lasers on drones, but there is research involving lasers. Another approach uses infrared laser pulses. There was an experiment back in 2010, University of Geneva researchers. They aimed these high-energy laser pulses into the air over Berlin.
What was the goal there?
The theory was that the laser pulses would encourage atmospheric gases like sulfur dioxide and nitrogen dioxide to form seed particles right there in the air, kind of creating the seeds on demand.
That sounds very cutting edge. Still experimental, though.
Oh yeah, definitely still in the research phase. But it shows the kind of innovative thinking going into this. But all these different methods, from planes to ground generators to drones and lasers, it really brings up a key question, doesn't it?
Quick gist.
If we can introduce these particles in so many ways, how precise can we actually be? And what does it really take to get the effect you want consistently in something as huge and chaotic as the atmosphere?
Yeah, that's the big question,
Look.
which leads us right into the effectiveness debate, I guess, because, like you said, there's skepticism. You hear about all these places doing it, spending money on it, but then scientists are still arguing if it actually works reliably.
Exactly. It's a critical point, and honestly, a really contentious one. Despite, decades of research, decades of actual application, its effectiveness is still very much debated in the scientific community.
So the studies are just all over the place.
Pretty much. Mixed results,
Yeah.
sometimes contradictory. Just last December, the U.S. Government Accountability Office put out a report confirming this ongoing debate. Experts just don't fully agree.
It's kind of wild, isn't it, to have something used so widely but still be scientifically uncertain?
It is. And the scientific community definitely has its share of skeptics. For example, a big study by the U.S. National Academy of Sciences, the NILA, they looked into it and basically said they couldn't find statistically significant proof that it worked consistently.
No proof. That sounds pretty definitive.
Well, maybe not no proof, but not strong, statistically significant support. A Stanford ecologist, Jerry Bradley, commenting on it, put it pretty well. He said something like, "I think you can squeeze out a little more snow or rain in some places under some conditions, but that's quite different from a program claiming to reliably increase precipitation."
Right. A little bit extra sometimes isn't the same as a dependable water source.
Exactly. And the NIFI study itself said it was, quote, difficult to show clearly that cloud seeding has a very large effect. Now, you compare that to, say, the Wyoming Weather Modification Pilot Project, the WWMPP. They looked at similar data, but were a bit more optimistic. They concluded that seeding could augment the snowpack, but by maybe a maximum of 3% over a whole season.
3%? That doesn't sound like a huge amount.
It doesn't, does it? But maybe in a drought, every percent counts. Still, it highlights the challenge. Is it a tiny, hard-to-measure gain or something more substantial? And how do you even prove that 3% wasn't just natural variation?
Yeah, teasing that out seems almost impossible.
And this skepticism isn't new. Back in 2003, the U.S. National Research Council, the NRC, put out a report that was pretty blunt. They said, science is unable to say with assurance which, if any, seeding techniques produce positive effects. Yet scientifically acceptable proof for significant seeding effects has not been achieved.
Ouch. That's pretty damning.
It was. And even more recently, a 2010 study from Tel Aviv University found little, if any, impact on the amount of precipitation from the common methods using silver iodide and dry ice. There was even a study in 2011 suggesting that airplanes might just be seeding clouds unintentionally, just by flying through them. freezing droplets around their propellers or wings. And that could potentially influence things like hail formation. It just adds another layer of complexity. Was it the intentional seeding or just the plane itself?
Man, it sounds like the science is really messy.
It can be. Lots of variables, hard to control, hard to measure definitively against the background noise of natural weather.
Okay, so you've got all this scientific uncertainty, the skepticism, but then people are still doing it. There's this whole other narrative of success, right?
Absolutely. There's a strong counter-narrative. Jeff Tilley from the Desert Research Institute argued back in 2016 that new tech and research have shown reliable results. He basically said it's now dependable and affordable enough to be a real part of water supply management in some places.
And didn't the American Meteorological Society say something positive too?
They did. Back in 1998, they stated that precipitation from supercooled orographic clouds, those mountain clouds we talked about, has been seasonally increased by about 10% in some projects.
10%? That sounds more significant than 3%.
It does. It suggests that maybe under very specific conditions, like winter storms over mountains, it can have a more noticeable effect, but specific conditions is the key phrase there.
Right. And then there are famous examples like the Beijing Olympics in 2008. They tried to use cloud seeding there, didn't they?
They did. The goal was ambitious. Make clouds rain before they reach the city to try and guarantee dry weather for the opening and closing ceremonies.
Did it work?
Well, that's debated too. Some claim success, others are skeptical. Experts like Roloff Brunches from NCAR pointed out, we cannot make clouds or chase clouds away. It highlights the limits, even with massive resources poured in.
Yeah, I bet they were sweating bullets hoping it wouldn't rain on the parade. Literally.
No doubt.
Yeah.
And then you have things like Project Storm Fury.
That was the hurricane one, right? The U.S. military trying to weaken hurricanes.
Yeah, back in the 60s. They seeded a few hurricanes and did observe wind speed decreases of 10 to 30% on some days.
Sounds promising.
It did, but the results were later questioned. They realized there wasn't much supercooled water in those parts of the hurricanes to begin with, which is what the seeding targets. And again, the huge problem of distinguishing the seeding effect from just the hurricane's natural fluctuations. It was ultimately inconclusive.
Okay. But what about that project in Thailand, the Royal Rainmaking Project? That sounds like it's been going for ages.
It has, initiated by King Bhumibol Adulyadej way back in 1955. And they make pretty strong claims of success across Thailand and even helping neighbors. They even got a European patent for their specific methods in 2005. It's a very established, nationally supported program.
So putting it all together, conflicting reports, debated science, but the practice just keeps going globally. Why? What does that tell us?
I think it tells us the perceived need is incredibly powerful. Water scarcity, drought, hail damage. These are massive problems. And cloud seeding, even with the uncertainties, offers a potential tool, a sense of agency maybe. So many regions continue to invest in it, hoping for that edge, that extra bit of water of protection, regardless of the ongoing scientific debate.
The hope outweighs the uncertainty, perhaps. Which brings us to the environment and health side of things. If you're putting stuff into the atmosphere, people are going to worry.
And they should. It's a critical consideration. Let's talk about silver iodide again, the most common one. It does have a health hazard rating, NFPA 704 rating of 2. That suggests it could cause temporary issues or maybe minor residual injury with really intense or chronic exposure.
Okay, a rating of 2. How bad is that, really?
It's relatively low on the scale, but the crucial context here is the amount used. Numerous detailed ecological studies have consistently found negligible environmental and health impacts from cloud seeding operations.
Negligible. Why?
Primarily because the quantities of silver iodide dispersed are absolutely tiny. We're talking minuscule amounts. Often, it's estimated to be about 1% of what various industries might emit into the atmosphere anyway in many areas. Perspective matters. You probably get more silver exposure from dental fillings.
Okay, so the dose makes the poison, essentially.
Yeah, exactly. The atmosphere is vast, and the dilution factor is enormous. And long-term studies, like one in the Sierra Nevada back in '95 and another in Australia in 2004, they looked for silver accumulation in soil, plants, water runoff. And they couldn't find levels significantly above the natural background levels of silver that are already there. It doesn't seem to build up over time in harmful ways.
But there have been concerns, right? I seem to remember reading about pushback.
Oh, definitely. Concerns are real and have a history. Back in the late 70s, for example, there was a broader concern about silver in the environment generally, not just from cloud seeding. An estimated 3,000 tons had been released into the U.S. environment through various activities. That prompted EPA studies and led to regulations under the Clean Water Act. So broader silver release did raise flags historically.
And what about specific seeding projects? Any controversies there?
Yes, a notable one was in Australia, over Kosciuszko National Park. It's a protected biosphere reserve.
Okay, sensitive area.
Very. Environmental groups raised serious concerns about the potential impact of elemental silver on the pygmy possum, which is an endangered species found there.
Ah, the possums.
Yeah, and also concerns about potential algal blooms in the park's pristine glacial lakes. Interestingly, an earlier seeding program in that same area back in the 50s was actually stopped, partly because the results weren't clear, and it had faced environmental objections even then, specifically regarding the possums.
So the debate isn't new there either.
Not at all. Now, it's important to note that the International Weather Modification Association strongly disputes these claims of negative impacts. They consistently point to peer-reviewed research showing minimal harm. But the controversy highlights that tension.
Yeah, it brings up that tough question again. How do you weigh the potential benefits, like more water, against even small environmental unknowns or risks, especially when the science on effectiveness is still debated? It's a real balancing act.
It truly is a delicate calculation of need versus potential consequence.
So let's zoom out again. How did this all start? Who first thought, hey, let's tinker with the clouds?
Well, the idea's been around longer than you might think. Back in 1891, an American inventor, Louis Gathman, suggested shooting liquid carbon dioxide into clouds.
1891. Wow.
Yeah, but the real scientific foundation came later, in the 1930s, with the Bergeron-Findeisen process. That was the theory explaining how ice crystals and supercooled water interact to make rain in cold clouds. And then, at General Electric, Vincent Schaefer and Irving Lamier experimentally confirmed this theory.
And Schaefer had that accidental discovery, right, with the freezer.
Exactly. That was the big practical breakthrough, July 1946. He was experimenting with creating supercooled clouds in a deep freezer, wanted to cool it down more, and tossed in a chunk of dry ice.
And poof.
And poof.
Yeah.
Millions of tiny ice crystals formed instantly. He'd stumbled onto a way to trigger that phase change reliably. It was easily replicated. A huge moment.
Incredible. Serendipity in science.
Totally. And then, almost immediately, his colleague, Bernard Vonnegut, yes, Kurt Vonnegut's brother, made another key discovery. He figured out that silver iodide, because its crystal structure is so similar to ice, worked really well too. That was another light bulb moment. He got a patent for it years later in '75.
And Kurt Vonnegut used the ice crystal idea in Cat's Cradle.
He did. Ice 9. A fun little connection there between atmospheric science and literature.
So when did they first try it outside the lab?
Very quickly. November 1946. Schaefer himself flew a plane over upstate New York near Mount Greylock in Massachusetts. He dumped about 6 pounds of dry ice into a cloud, and sure enough, snow started falling out below. The first real field test.
Amazing. From freezer discovery to making it snow in just a few months?
Yeah, these early discoveries really established that dry ice and silver iodide were effective tools for manipulating supercooled clouds. Good for boosting winter snowpack over mountains, maybe even suppressing lightning or hail sometimes. And more recently, there's been that revival of interest in hygroscopic seeding, using things like salt for warm clouds, trying to make bigger droplets that fall as rain more easily.
Okay, so the U.S. government saw this potential early on.
They did.
Yeah.
Federal agencies got involved pretty heavily for a while.
Here's where it gets really interesting, the military connection, too.
Right. Agencies like the Bureau of Reclamation ran Project Skywater from the mid-60s to the late 80s, focused on winter snowpack enhancement in the Rockies and Sierras. NOAA had its own atmospheric modification program for a good stretch, too, into the early 90s.
So lots of research projects.
Yeah, specific ones like the Sierra Cooperative Pilot Project in California, HIPLX for convective clouds in the plain states like Montana, Texas. Though federal funding for this kind of research did decline quite a bit in more recent decades, there was a smaller weather damage modification program in the early 2000s, but not like the big projects of the past.
And the military involvement, Operation Popeye.
Ah, yes, Operation Popeye. That was definitely significant and controversial. U.S. military, 1967 to 1972. They were seeding clouds with silver iodide over the Ho Chi Minh Trail in Vietnam during the war.
To do what?
To extend the monsoon season, make the trail muddier, harder for enemy troop and supply movement. The unofficial motto was, make mud, not war.
Wow. Weaponizing the weather, essentially.
And that's exactly what it's perceived as. They reportedly managed to extend the rainy season by 30 to 45 days in the targeted areas.
And that, combined with Storm Sherry, the hurricane project, It really shows that strategic military thinking was part of this early on.
Absolutely, which, as we discussed, later fueled a lot of distrust and conspiracy theories.
Right. So beyond the US, this went global pretty fast, didn't it? You see it everywhere now.
Well, absolutely. It's a worldwide phenomena. Let's take a quick tour.
Okay, where should we start? Asia.
Sure. Asia is huge for cloud seeding. China has the biggest system globally. They use silver iodide rockets extensively, especially in arid regions like
Huh.
around Beijing. Remember the Olympics? They used it before the 2008 games for dry weather. Then in 2009 to trigger snowfall after a bad drought.
And they use it for pollution, too.
Yeah, they reportedly used it in July 2021 to clear the air, literally wash out PM 2.5 pollution before a major CCP event by forcing rain the night before. It even led to political friction, this idea of cloud theft between provinces,
Ah, stealing rain clouds. That's amazing.
isn't it? Elsewhere in Asia, India has used it during droughts. Pakistan just did its first experiment with UAE help to fight smog in Lahore. Indonesia uses it against flood risk in Jakarta and to combat haze from fires. The UAE, as we mentioned, is a leader in the Gulf region, desperate for water in that heat. They claim rainfall increases of 10 to 35% depending on conditions.
Okay, what about Southeast Asia?
In Southeast Asia, a big driver is combating that cross-border haze from agricultural burning. Malaysia, Thailand, Vietnam, Sri Lanka have all used it for that, and also for things like filling dams. Malaysia started back in '88, even did daily seeding during a bad haze in 2015. Thailand's Royal Rainmaking project is, like we said, a major national effort since 1955. Even way back, the French considered using it in Vietnam during the Battle of Dien Bien Phu in '54 to bog down supply lines, though apparently didn't work well then.
Fascinating history. North America, still active here.
Definitely. In the United States, it's still used, especially out west. Increasing precipitation in drought areas, reducing hail, dispersing fog at airports sometimes. Ski resorts are big users, trying to boost their snowfall. As of about 2012, 11 western states plus Alberta in Canada had programs. California agencies report maybe 3–10% more snowpack in the Sierras from their efforts.
And can
Canada, particularly Alberta, has the Alberta Hail Suppression Project. It's funded by insurance companies to reduce crop and property damage from severe hail. A clear economic driver there.
Makes sense. Europe.
Europe, too. Bulgaria has a national network of rocket sites just for hail protection, claims it saves huge agricultural losses. France and Spain started in the 50s, also mainly for hail reduction. Russia uses specialized planes, famously seeds clouds, to try and ensure dry weather for Moscow's May Day parade. They've also used it against Siberian wildfires and drought in Crimea. Germany, Austria, Slovenia all have active hail prevention programs, often run by local groups.
Okay, Australia and Africa.
Down in Australia, CSIR ran early trials with mixed results. Hydro Tasmania had a long-running program they deemed effective in boosting rainfall. Snowy Hydro also ran trials, and recently they even trialed marine cloud seeding off Queensland, spraying salt water to brighten clouds and shade the Great Barrier Reef, trying to reduce coral bleaching. A totally different application.
Wow, protecting the reef with cloud seeding. That's novel.
It is. And in Africa, countries like Mali and Niger use it nationally. Morocco has had a program since the 80s. So yeah, it's truly global.
So what does this all mean? The sheer scale, the variety of reasons. It really hammers home that perceived need, doesn't it? Even with the scientific questions lingering.
Exactly. The global footprint is undeniable. Which brings us neatly to the legal side. If everyone's doing it, what are the rules?
Right. Is there any international law governing this?
There is, but it's limited. The main one is the EMOD Convention, the Convention on the Prohibition of Military or any other hostile use of environmental modification techniques.
Sounds like it came out of that Vietnam War stuff.
Precisely. It arose after Operation Popeye and Cold War fears about weather warfare. But here's the crucial point. ENOD only bans military or hostile uses. Peaceful uses, like making rain for crops or filling reservoirs. Not prohibited by ENMOD.
Ah, so it leaves a pretty big gap.
A huge gap. And it's criticized for being vague, leaving lots of room for interpretation. What constitutes hostile? What about effects that cross borders unintentionally? It's largely unregulated internationally.
Which leads to that really thorny question, maybe the most interesting one, who owns the clouds anyway?
Huh. Yeah, that's the philosophical but also practical problem. Way back in 1948, a Stanford Law Review article basically said, assigning legal title to a cloud is ridiculous. They move, they change, they cross borders. You can't really own them like land.
So what are they, legally speaking?
Well, there are these concepts. Res communis means something belongs to everyone, like the high seas or the air. Ideally, it needs international rules. Res nullius means it belongs to nobody, so states or people can potentially claim it or use it freely. Water resources often fall into this category, though there's pressure to treat water more like res communis now.
And where does cloud moisture fit?
It's undefined, really. It lacks a clear legal status. But the argument some make is, once you make the moisture accessible, you make it rain through seeding, maybe then you can occupy or claim it.
You turned it from potential into actual water.
Kind of. In California, they try to tie seeded water to existing water rights, treat it like natural flow. But potentially, a court could say, no, this is additional precipitation, and maybe let the entity that did the seeding claim it.
But how would you ever prove how much was additional?
Exactly. That's the practical nightmare. Measuring that fraction is incredibly difficult, maybe impossible.
So it raises huge questions. If you make it rain, is it yours? What about your neighbors downstream or downwind? Did you take their potential rain? It's mind-boggling.
It really is. Deep ethical and legal waters with very few maps.
And this fuzziness, this sense of control, even if it's debated, that probably feeds into the conspiracy theories, right?
Oh, absolutely. It's crucial here to be crystal clear. Cloud seeding is not the chemtrail conspiracy theory.
Right, they get conflated all the time online.
All the time. Cloud seeding, as we've said, requires existing clouds to work on. You're modifying something already there. The chemtrail theory alleges things are being sprayed in clear skies, leaving persistent trails, which scientists explain as normal contrails under specific atmospheric conditions. They're fundamentally different things.
But the fact that governments have intervened in weather, like Operation Popeye, that fuels suspicion, doesn't it?
Undeniably. When people learn that governments or militaries have tried to manipulate weather even decades ago for strategic reasons, it feeds speculation. People start wondering if they're doing it now for other reasons, controlling global warming, controlling population secret weapons tests, you name it. It taps into existing distrust.
I remember that story about LA County putting out a classified ad for cloud seeding.
Yeah, in 2016, it was just a standard ad for their long-running, totally public anti-drought program. But online, it instantly blew up as proof of secret, widespread weather modification. They had to issue clarifications.
It just shows how easily that line blurs, doesn't it?
Yeah.
Between the actual science, the historical interventions, and then public skepticism or outright conspiracy theories.
Yeah.
Especially with something as fundamental as the weather.
Very blurry indeed.
Okay, so let's shift gears slightly. We've been talking about literal rainmakers. But that term, rainmaker, it's used in business too, right?
Oh, yeah, absolutely. In business, a rainmaker is that star performer, the person who brings in the big clients, the crucial deals, loads of revenue or prestige.
Someone who makes things happen, even when times are tough.
Exactly. You find them in law, finance, sales, anyone known for driving success and innovation, for closing the deal. They make it rain, money, or clients.
It's interesting how that term bridges the literal and metaphorical, but what if we bring it back? Are there modern, tech-driven, literal rainmakers now?
Well, it's funny you should ask. There's actually a startup called Rainmaker Technology.
Seriously? Called Rainmaker Technology?
Yep, based in El Segundo, California. And they just raised $25 million in Series A funding.
Wow, what's their pitch?
Their mission statement is pretty bold. Making Earth habitable.
Okay, no small goals there.
None at all. They aim to provide water for farms, watersheds, ecosystems. They describe their tech as the only immediate, scalable solution to create abundant fresh water through precipitation enhancement.
So they're literally aiming to be modern rainmakers using advanced tech.
Exactly. They're leveraging all the latest stuff we've touched on, advanced drones, sophisticated weather modeling, better radar algorithms, and importantly, what they call sustainable cloud seeds, trying to be effective and environmentally conscious.
And what are they aiming to do with it?
The stated uses are wide-ranging, supporting agriculture, shoring up water supplies for communities, stabilizing hydroelectric power, fighting drought, even helping restore natural ecosystems damaged by lack of water.
So that term rainmaker, it really has come full circle, hasn't it? From the literal weather attempts to the business metaphor, and now back to literal rainmaking, but supercharged with modern technology like drones and AI-driven modeling.
It's a perfect convergence, really, using cutting-edge tools to address those fundamental needs. Water, resources just like the earliest attempts, but hopefully with more precision and understanding. It represents that drive to find solutions for critical challenges.
It really does. Okay, as we start to wrap this up, any final thoughts on this whole complex picture of cloud seeding?
I think it's worth reflecting on that duality we've seen throughout. This persistent human desire to influence nature, right? From ancient rain dances to silver iodide rockets and sophisticated drones, we've seen the science, the debates, the global efforts, the legal tangles, the ethical questions, and maybe now facing accelerating challenges like global water scarcity, climate change impacts. The key question isn't so much can we influence the weather anymore. We know we can, at least to some degree, sometimes. The more pressing question is how responsibly, how ethically do we integrate these powerful capabilities? How do we use them wisely, considering the complex, interconnected environmental systems we're part of? And maybe even what does it mean for our fundamental relationship with nature when we transition from being just observers or even victims of its whims to being active participants, shaping the rain itself? It's a profound shift to consider.
That is a really profound thought. How does our role change when we gain that kind of power, however limited it might still be? Definitely something for all of us to mull over. Well, thank you for joining us on this deep dive into the fascinating world of cloud seeding. It's been quite a journey through science, history, and ethics. And speaking of powerful solutions, especially for managing critical data reliably, if you're looking for robust and secure enterprise storage, definitely consider Stonefly. They offer a comprehensive portfolio for all kinds of enterprise needs, and right now they have an incredible offer on their 100 TB immutable and air-gapped SSO NAS available for just $8,995. That's a solution designed for top-tier security and data integrity, which is more important than ever. Check them out at stonefly.com.
We really hope you gained some valuable insights today. Until next time on TechDaily.ai, keep learning, keep questioning, and keep exploring the deep dive.